Hello everyone, welcome back to my channel. Today let's solve Leetcode problem 1625 lexicographically smallest string after applying operations. You are given string S of even length consists of digits 0 to 9 and two integers a and b. You can apply either of the following two operations any number of times in any order S. Add a to all odd indices of S. Digits post 9 are cycle back to 0. Okay, so here if you see they have added 5 to 4 and 6. The resultant string is 3951. Rotate S to the right by b positions. Okay, so here b is 1, that means we have to rotate by 1 position, that means 6 will come to the beginning. 6 3 4 5. Written lexicographically smallest string you can obtain by applying above operations any number of times on S. Okay, there is no restriction on how many times you can apply. Either you have to apply addition operation or you have to apply rotation operation any number of times. Okay, after applying all these operations, if the resultant strings are arranged in a sorted order, what would be the first string in the sorted order of the transform strings? Okay, so this is pretty good problem. Okay, the rating, if you see, the rating is also 1992. It's a good medium level problem, I would say. Let's jump back here. Okay, so I have taken the first example 5525 and a is 9 and b is 2. Okay, so for a given string, either we can choose to rotate or we choose to add. Okay, there are two possibilities at each position. Okay, if we choose to rotate it by two positions, then the resultant string would be 25555. Okay, so the last two positions have been moved to the beginning of the string. Okay, if I choose to add 9 to all the odd indices, okay, so 5525 I have to add 9 to all the odd positions. That means the first position I have to add and the third position I have to add. The resultant would be 5425. Okay, if you add 9 plus 5 will be 14 and we have to circle back. Okay, we have to take a floor by 10. Okay, I mean we have to take the remainder by dividing it with 10. Okay, so that means at any point it should lie between 0 to 9 itself. So as a result we are taking modulo operator with 10. Okay, yeah, so again if you see these two are the resultant strings which were formed after transforming. Again for these two, again we have two more options. Either I choose to rotate or I choose to add. Okay, if I choose to rotate it, okay, that means this is the string which was formed. Okay, if you see this and this string are both the same. Okay, that means I should not process it again, because if you keep on processing, the same outputs would come. Okay, so we need some kind of data structure which will help us to eliminate the strings which were already processed. Okay, so we'll keep a hash set. Okay, and we'll keep on pushing the elements into hash set which were already processed. Okay, so initially there were no elements in the hash set and we'll say that this element we have processed and we push into hash set. Whenever we encounter this string, we first check at each position. We'll first check whether this particular string was processed previously or not. If it is not processed, then only we'll further process it. Okay, so there are two approaches in the explanation itself. If you notice, at each step I'm taking two possible actions, right? You can straight away apply DFS, okay, and explore all the possibilities, or you can apply BFS. Okay, both the approaches you have to solve. You can use to solve this problem. If I go with BFS approach, okay, first I will take this string and I will get all its neighbors, all possible neighbors, and I will push them into the queue. And again from the queue I will pick one element. If it was not processed previously, then I will further get its neighbors and I will push into the queue. Okay, so let me show you the code. Okay, as I mentioned, we need a hash set which will help us to keep track of what all elements I have seen so far. So, and we also need a queue in order to apply our BFS. Okay, so first I will push my initial string S into my queue so that I can initiate my BFS algorithm. and initially I also kept a variable called smallest, which will help me to track what was the smallest which was encountered so far. Okay, so as long as my queue is not empty, I have to perform some action. What is that action? I will just pull the first element from the queue. Okay, I will pull the first element from the queue and get its neighbors. Okay, first I will check whether this is processed PS not. If it was not processed, then only I will get its neighbors. Okay, so that is what I am doing here. First I am checking whether it was seen previously or not. If it was seen, then I don't have to do any action. If it was not seen, I am marking it as I have seen and I am getting its neighbors. Okay, and in the similar process I will also update my smallest. Okay, if the current element, if it is smaller than the existing smallest string, that means I will update my smallest. And there are two possible actions: either I have to add or I have to rotate. What does add function does? It does add a to all its odd positions. Okay, I will start at 1 and I will increment by 2 so that I will get all odd positions. Okay, and then I'm just taking I'm adding the current number and I'm making sure the resultant number will lies between 0 to 9. That's the reason I'm taking modulo by 10 over here. And then I'm just resetting the current index character with the new character. Okay, this would help us to add all the odd positions with a. Okay, and other thing is, the next possible step is to rotate the string. Okay, so the last b character should be my first b characters. Okay, so the first index of the last b character would be n minus b. So from that particular element all the way till the end would be my first part of my string, and from starting till that particular position would be the next part of my string. Okay, so I've got both the strings and I will simply offer it my queue. Since in the initial step itself I'm taking care of whether I have to process the seen or unseen elements. I don't have to again add a check over here and add it back into the queue. Okay, so in the end my smallest would contain the smallest string, which is lexicographically smallest. And then yeah, that's all. Let's try to submit this. As you can see, all the basic test cases were passed, and if I try to submit this problem, all the test cases were also passed. Okay, this is pretty efficient solution. It has beat almost 78% in terms of memory, and it has also beat in the runtime. Okay, it's a very good approach. Let's try to analyze the time complexity and the space complexity. Before analyzing the time complexity and space complexity, I request my viewers to subscribe to my coding channel. I've noticed that people are watching my videos but not subscribing to it. Okay, I highly recommend you to subscribe so that you will also grow along with me on daily basis and improve your problem solving skills. Okay, so let's analyze the time complexity. So at each position, okay, if you see all the odd positions, we are adding the number. Okay, and the outcome of this number can lie between 0 to 9. Okay, so there are 10 different possible numbers which are possible for odd positions. Okay, and if you see, if b is 1, okay, that means if I rotate my string by one position, that means all my even positions would become odd positions. Okay, so in this case, even the even positions has a possibility that the corresponding characters by adding a to it will also range from 0 to 9. Okay, so it also has 10 possible variations, right? So the total time complexity would be 10 times 10 times s into length, because we have to generate all these unique possible strings, and then I have to calculate this, and then I have to identify the smallest one. Okay, this way we have to basically generate all those possible combinations. As a result, the time complexity would be this. And what would be the space complexity? Okay, at each position I'm actually checking in my hash set whether this element was processed or not, right? So my hash set will also grow up to this particular length, right? Up to this particular length, so the overall time space complexity of my algorithm will also be the same. Okay, so time and space complexity is 10 times 10 times the s dot length, and space complexity also the same. Yeah, that's all about this problem statement. Do subscribe to my coding channel for more such coding videos. Yeah, and also advance happy Diwali. Yeah, thank you.